So hi guys, I got this, I think it is Irobot battery from a friend of mine that said that it suddenly stopped working, and you can see by the size and the build that there are 3 cells inside. It's written voltage 12.3, which is reasonable, more or less. And let's first try to measure the tiny contacts here, plus and minus. So I will try to connect and see what is the voltage of this, because it said that it suddenly stopped, and before it stopped it worked very good for 1.5 years. So I see 10 volts. So this is not bad, but probably there is a problem with it. So I'm pretty curious to know if there is a BMS inside, any battery management system, or maybe the battery management system is in the Irobot device inside, and these are just the cells, because it can be, because we can see we have 1, 2, 3, 4 contacts. So we need if we have 3 cells, so we need the plus and the minus, and then 1, and yes, we have enough contacts. You need exactly 4 contacts if you want to do the balancing, because you have to connect at the total plus, the total minus, and then you have 2 points in the middle, first after the minus, let's say it is here, and then after the second battery it is here. So you need exactly 4 contacts, and the BMS can be in the other unit of the Irobot. So I'm pretty curious to see if I can open it without damaging it, and I don't have a good idea if to cut it here, maybe just to try to open it from here will do the work. Maybe this first to remove this mounting screws. So let's try to find out what can be done. Find a good, not a good, I didn't find at all any video how to do it. And here is how you do it. Very simple, just apply power and it goes out. You can see there is a rubber for sealing from water, and you have the BMS here inside the battery, which is the best way to keep it. And now we will see if first I can gently remove things out without damaging and shorting, and I don't know about the situation of this battery. So first, if you will notice very closely, first time I'm doing it, I've never done it and I'm not familiar with this model. There is a Phillips screwdriver here, tiny one, and this will not open it. So I'm searching for a stronger one. Yes, this will do the job. Of course, be careful not to short, so I don't know about the situation of the batteries. There is some clips here, probably I can pull it out, but I want to be very careful with the short. Maybe I need to discharge first the batteries. There is something here. Okay, I will first maybe if you will notice what I can do, I can remove the contact of the batteries. I have 1, 2, probably this is 3 and 4, and maybe this is, where is the third battery? The third battery is here, so where is the contact of the third battery? Because I need 2 contacts from each battery. I have 1, 2, 3, 4. I'm missing 2. So maybe there is a wire going from the third one. I'm not sure, but let's first measure each cell to see if they are not balanced. So maybe this is why it failed to work, because the cells were not balanced. So I guess this is one battery, 3.4. This is the second, 3.4. So I'm not sure about the third, but maybe if I will go now, this is measuring something else. So by the way, the batteries are almost totally discharged, because if they are fully charged, so it should be 4.2, and it is not. So the big question is if it is a cell problem or a BMS problem, which is always the case. It is very hard to understand. There is a tiny microcontroller here, and then we have another chip here and here. So protection circuit is probably good enough. So I want to remove this board out. I guess I will need first to remove soldering from here, 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 and gently do it without shorting anything, or discharging the battery to a lower level before doing all these interrupts to the battery. So I think I will fully discharge it to 3 volts, and then I will disassemble 3 volts. If the battery is okay, it will still work. I will not kill it. And about polarity, probably this is the minus and this is the plus. Yes, and also probably here is the same. This is the minus and this is the plus. Yes. And the third battery, I don't know where it is connected, so I have no clue. But of course there are 2 other contacts for the third battery. It should be here. So first we'll discharge these 2 cells, and then we'll see how to remove the solder and try to remove the PCB, and then later remove the cells outside. So I will start with a safely discharging. Okay. So I'm just soldering the first 2 wires that I have found. So of course it's more preferred to do it with the correct colors, but this is what I have right now. So the purple will be the plus and the blue will be the minus. Now we will do a fully discharge for this one. So this should be the minus, this should be the plus, and I have here the B6. So I will go to Eco battery, and now I don't have 6 cells, I have only 1, and I want not to do a charge, I want to do a discharge. So the cells are almost empty. I'm sure there is a third cell that I can get to it, so I don't really know how to discharge it, but it is there, and I'm not sure how it is connected. So I will now remove the wires, the discharging wires, and I will remove the solder from here all the points, and I will try to take up the board. So of course, in this tiny amount of energy, there is no danger with lithium cells. The danger is only if they are fully charged and things like this. So I don't really afraid to do it. You shouldn't be afraid. You just should know about the limitation of the cells and how to take care and be cautious about it. So now let's remove the parts that I think that I need to remove in order to take it out. So I'm using a vacuum in order to do is add a solder in order to spread the heat, and then sometimes it's easier to remove it, like here. So look what we found here. This is, by the way, the temperature meter. It is the TH1, and there are 3 cells inside, as I thought, but only balancing 2 of them. This is no, we have 4 wires, so we are okay. If we have 4 wires, so everything is connected okay. Now there is a sticker here. Okay, so we can remove also the sticker. And now, there is another plastic cover. Of course, everything is in order to prevent shorts on this one. Okay, how this plastic is cut, so probably it is heated or melted somewhere here. Maybe we can remove all the cells with the plastic. By the way, now I can know what is the voltage of the last cell, because it is exposed from here to here. So 3.4 like the other cells. Exactly the same. So now let's see how we can take it out. It is melted in some places here. Now you can take everything out. You see it? Let's go out like a charm. Haha! Here we go. So here are all the cells. So basically this can be changed. So we have the positive, and here is the positive by the line here. This is the positive, so this is the negative, yes, and this is the positive. So of course you need to remember the order in order to connect everything back. Maybe I will write it down. I will write it down because you don't want to mess with it. So how will I do it? I can write it on plastic. I will show you how. So I will just use the same plastic that I used here, and then I can mark everything on the plastic. So let's do it. So if I look, so I have this one is the positive, this one is the positive also. Okay, I did mark it, it's hard to see, but I did mark. And this is the negative. Here we have a negative. And this is what we need to know. And to be on the safe side, I will write it on a paper. So, forgive me about the mess here. So let's write it down. So if this is the bottom side, let's go like this. This is the bottom. Yes, and let's go up. Okay, and this is the upper side, something like this. So we have here plus, and here also plus, and here we have the minus. So here is the minus, here is the minus, and here is the plus, and the connection is this one is connected here like this, and this is one side, and this is the other side, and okay, and then we have two wires on the bottom. This one is connected of course to this one. Any other way it will be shorted. So maybe I will focus on it. Okay, so we have plus, plus, and then the minus. Maybe I will mark it like this, it will be more clear. So this is the bottom, this is the top. So we have connection here, and we have the two wires. So one wire go from between these two wires up on this side. So this is one wire, and the other wire goes from the plus here, and this is probably the output. So this is the other wire. So this is the plus for all the battery, and this is the minus for all the battery. Basically this is all. Now I will test the cells, the broken cells, and I will replace to my friend with a new cells, and I will try to assemble everything back. This is not very easy. Maybe I will use the same wires here somehow. Not really sure yet. By the way, these are Sanyo cells. There is a logo of Sanyo on this lithium. Basically this is all. So I will try to assemble everything back, and we'll see if everything works. Thank you and bye. Okay, so eventually I'm a little confused because all the cells have more or less 1700 or 800 milliamp hours. So this is very strange, and I am starting to think that maybe the BMS PCB is the problem and not the cells as I have suspected. So we will now try to see if we can find something in the PCB itself, or this is the only guess I have right now. So continue to test it, and then we will come to conclusion, hopefully. So after doing some investigation, I have no idea what is wrong. I think everything is okay, and I will close it in a minute. But first I want to show you a few things that might help you to debug it. First, if you see there is diode here, D6SC. This is a 12 amp diode. Not exactly diode, this is a fuse with a heater. The heater is from here, which means you have a fuse from this side to this side of 12 amp, and if there is an emergency issue of overcharge or overcurrent or over discharge, it will protect the cell and of course disconnect the battery. This is why it is connected to this pad here, which is the positive side of the battery, LP4. Another thing to be note is that there are two MOSFET here. The MOSFET here disconnect the minus of the battery, so these two MOSFET go to the connector side. So if you will measure continuous from the minus of the battery, you will not be able to see it because it's on the other side of the MOSFET. So eventually you will see the plus is going to the connector, but the minus is through this MOSFET. A few other things. There is a microcontroller here for doing all the management of the BMS, and there is also beside the temperature sensor of the fuse that automatically disconnect when it is emergency case. You have, I think I showed it, you have here a strip with a sensor heater. It's like a temperature meter to disconnect the battery if the controller thinks that something is too hot. Other than this, all other component looks okay. There is also a measurement resistor, probably 3 milliohms, that measure the current that is going from the battery to the Irobot, to the device, so it can know how much voltage in the battery and know the situation of the battery and the discharge and charge currents. Other than this, I don't find anything, so I will close everything. So maybe my friend has problem with the charger of this device, so I will connect everything. I will try to charge it from the connector directly a little, and then I will bring it back to him, and he probably will retest it. I guess it will be okay. So let's try to close everything back when I know that the batteries are fully okay, and then we'll see how it looks when it is fully assembled back. So before connecting everything back, it's a good thing to check that my cells are balanced. So of course I did bring them to the same voltage to be balanced, so let's check. So 3.4 and 3.4 and 3.4. So this is okay. This discharge level is not dangerous even if there is a short. Hopefully I remember how to connect everything back. I did a minimal braking when taking all the parts out, so I guess I will be able to close everything back smooth and nice. So let's see if I remember. There was the first thing, if you remember, this nice sticker. It was here somehow, probably it was like this, to protect from shorting the cells. So this is the sticker. I left 2 pieces of the wire. Hopefully I can connect them back exactly to the same place. It will be a little difficult, this thing. Also, it's the opposite sides also. So almost first explode, but we did prevent it. So now, wow, it will be very difficult with the wires. So maybe I have another idea, and this is because I don't think that I can be exactly in the right place for these tiny wires. Let's see if it is possible at all. No way. So I will have to flip it to the other side and then do it. I think this is by the way, the only way to do it. So I will have to take it out now. So this is the first part. Put in the batteries in the second. So I think it will be easier, if you understand me, to put it like this. And now I have ability to play with it while placing the wires at the correct place. Tiny wires. It's not that easy. Maybe it's a good thing to replace the wires, but I want to do as less change as I can. This is much too complicated to do it like this. We will try again. Because you have to be exactly near the end of these tiny wires that are already cut. Maybe I have an idea to put a little solder on the wire so they will not split while entering everything back. Maybe it's a good idea to do it. Let's see in a minute. Maybe I can stretch the wires a little higher. It's not easy. Believe me, it's not that easy. Take everything apart is easy, to fix it back it's always much harder. Okay. Try to squeeze a little the end of the wire. Aha, I have another idea. First, I will put the parts that I can solder, and then I will try to put these tiny wires. Okay, this is a good way, I think. Okay, I will first put this soldering pad. Is a little problematic to enter, so maybe I will hit it. Yes, and then it enters pretty well. And now, when it's already inside, maybe I can already solder this part. And this part also. So now let's put everything back in its place. Something like this. Okay, and now just need to close this part with the clips. And now there are two screws. And another one. And I guess this is all now. About the voltage, I think there is no voltage right now. I think so. Let's do a quick another check.